Hello everyone. Before starting this lesson, please pause the video and try this warm-up where you're to solve the triangle. That means you need to find this missing side length and both angles. So pause the video and try it. Hopefully you were able to try this question. These are the answers I got. The hypotenuse is 15.3 feet, the top angle is 11 degrees, and the bottom angle is 79 degrees. This is how I did it. I found the missing side length using the Pythagorean theorem. I found the bottom angle using the tangent ratio. I knew I could use tangent because from this angle, 15 feet is opposite, 3 feet is adjacent, opposite and adjacent, I know I use tangent. So when I solve that, I get 79 degrees. And then to find the top angle, which I've labeled as B, I knew that all three angles inside a triangle have to add up to 180 degrees. So if I take this 90-degree angle and this 79-degree angle away from 180, whatever's left over is the angle at the top, 11 degrees. You may have solved this problem in a different way, but we should get approximately the same numbers, no matter how we do it. Now we're going to move on to the lesson, so please take out this sheet in your notebooks. Pause the video if you need time to do that. And the goal for this lesson is to be able to solve multi-step trigonometry problems. So up until now, you've been able to solve most problems just by doing one calculation. But now we're going to look at problems like these that you see on your sheet, and they require more than one step in order to solve fully. So let's start with example 1. Determine the length of AB to the nearest tenth of a meter. So the length of AB, well, that's the line from point A to point B. It's this line right here. And because it's across from angle C, I'm going to label it as C. Now, if you look at this triangle that I'm highlighting, we don't really have enough information in that triangle to calculate the length of C. All we know in this triangle is two angles. We know there's a 90-degree angle and a 30-degree angle. So we could figure out this angle here, but because we don't have any side lengths, that's not enough information to figure out the missing side length. So we need to know a side length. And that leads us to the other triangle. If we look at this one, ADC, that triangle right there, we know a side length and we know two angles. We have enough information that we could solve for this side, AC. And then once we knew that side, then we would have enough information in this highlighted triangle that we could solve for side C. So here's my method. I have this angle as my reference. So there's the opposite side. The 12 meters would be adjacent to that angle. So opposite, adjacent, I'm going to use the tangent ratio. So tangent of 70 degrees equals, we'll call this D over 12. Opposite over adjacent. So now if I look at this equation, my unknown is on the top of the fraction. So to solve for this, I need to get rid of the 12 by doing the opposite operation. So instead of dividing by 12, I'm going to move that over here to be times 12. So 12 multiplied by the tan of 70 is equal to D, and that's approximately 33 meters. Now that I know this side length here is 33 meters, my highlighted triangle, triangle ABC, has enough information that I can solve for this missing side length. Side C is going to be the hypotenuse because it's directly across from the right angle. And because angle A is my reference angle in this triangle, straight across to this top side, that's the opposite side, which makes this side the adjacent side. So now I have to keep the goal in mind. My goal is to find the length of this side, which is the hypotenuse. So that has to be in the equation. Hypotenuse must be in the equation. I need another side that I know. Well, the only other side I know is this one. It's 33 meters. I can't use the opposite side because I don't know its length, so this adjacent side is the one I'm going to use. So hypotenuse and adjacent both have to appear in my equation. So I need to decide, do I use sine, cosine, or tangent? Well, it's because I need to have adjacent and hypotenuse, I'm going to use the cosine ratio. So the cosine of 30 degrees is equal to adjacent, so 33, over hypotenuse, c. And because c is on the bottom of the fraction, to solve for c, it's going to be 33 divided by cos 30. And when I do that in the calculator, I get about 38.1 meters. So the final answer to the question is the side AB is equal to 38.1 meters. Now in the future, if you get a question that looks similar to this, where you have two triangles joined together, the key is going to be figure out the length of the side that they share, and then that will lead you to get more information in the triangle that you're trying to find the information about. Let's try the next one. Same question. We're trying to find the length of AB. So this little length right here. Now, I'm not going to call it D because it's unclear. Since point D is here, does D represent this side or does it represent this one? It's a little unclear. So I'm just going to give it a different label. I'll just call it X. Now in this question, it's a little bit different because this skinny triangle here is not a right triangle. So if we found the length of this shared side between the two triangles, it wouldn't help us because we can't use sine, cosine, or tangent in a non-right triangle. So that's not the route we're going to take this time. But I want you to notice this. There's a large right triangle from D to A to C, and there's a small right triangle from D to B to C. So there's two different right triangles in here, and for both of them, we can figure out the length of the far side on the right. So if we looked at the small triangle and calculated the length of this side here, BC, and then if we looked at the big triangle and calculated the length from A to C, we could subtract the small one from the big one, and whatever's left over would be the distance from A to B. So that's the method I'm going to follow. Now I'm just going to give one-letter names to these sides. So this side here from B to C, I'm going to call that Y. And the entire side from A to C, I'm going to call that whole thing Z. So I've got X is what I ultimately want to get. Y, I'm going to find that first. Z, I'm going to find that second. And Y, taken away from Z, will leave me with X. So Z minus Y gives me X. Now this is how I'm finding side Y. If I look at the triangle that I've highlighted in blue, my reference angle is 35 degrees. The opposite side is Y. The adjacent side is 200. So opposite and adjacent need to be in my equation. That means I'm going to use the tangent ratio. So tan of the angle is equal to opposite over adjacent. So tan 35 equals Y over 200. Now to solve for Y, it's on the top of the fraction, so it's going to be a multiplication of 200 and tan 35. 200 multiplied by tan 35. And when I do that in the calculator, I get 140 meters. So this side length is 140 meters. Now find what I've labeled as Z, the distance from A to C. It's this big triangle that I've highlighted in green here that we're going to use to solve this problem. Now just be careful because this 35-degree angle is here. This 7-degree angle is here. But the angle we need to use is the angle all the way combining both of those angles. So the angle we're actually going to use here is 35 plus 7, which is 42 degrees. So the angle that we're using as our reference angle is 42 degrees. Z is the opposite side. 200 is the adjacent side. So opposite and adjacent, we're going to use tangent again. So tan 42 equals Z over 200, which means Z is equal to 200 multiplied by tan 42, and we get an answer of about 180.1 meters. Now we're not quite done the question yet because remember, we're supposed to find the length from A to B, which I've labeled as X. So we need to take the length of Z, that entire length, and subtract the length of Y, and then we will get X left over. So we will do 180.1 minus 140, and that gets us a distance of 40.1 meters as our final answer. Now let's move on to example 2. This is an example of a word problem. So anytime you have a word problem, it's a description, right? So you got to picture what it's trying to tell you. Try to visualize the situation. And we know, because this is a trigonometry question, that we're going to have triangles in our drawing. So try to imagine, as you're reading, what do the triangles look like? Godzilla stands on top of a building that is 75 meters away from you. His feet have an angle of elevation of 38 degrees, and the top of his head has an angle of elevation of 51 degrees. How tall is Godzilla? So it might sound a little confusing at the start, but try to imagine what it looks like. You've got Godzilla. He's standing on top of a building. Start by drawing that. The building is 75 meters away from you, so place where you are standing, somewhere on the ground. His feet have an angle of elevation of 38 degrees. Well, elevation, that's looking upward. So from where you're standing, looking up to his feet, it's 38 degrees. The top of his head has an angle of elevation of 51 degrees. So from where you're standing, looking up to his head, it's 51 degrees. So this is the drawing that we have. And we're asked to find how tall is Godzilla. And I've labeled that as X. So X is the distance we're trying to find. Now the other thing I want to add here is anytime you're dealing with any kind of structure like a building or a tower or pretty much anything man-made, we don't build crooked buildings. So the building's standing straight up, we can assume there's a right angle in here, which allows us to use the trigonometry that we've been learning about. Now, this drawing here, even though it has Godzilla in it and a picture of a little person down here, I want you to notice that this question is actually pretty much the same thing that we did in the previous example. Imagine Godzilla's on top of the tower, that's X. We have an angle here, we have a big angle here. We have a distance at the bottom. We're going to follow the same method actually to solve the Godzilla problem as we did here. So I'm not going to spend a whole lot of time going through it because it's the exact same question, but I'm going to give you some time to look at my solution. So I'll get the solution on the screen here, and then feel free to pause the video and write it down. So I started by looking at the small triangle with the 38-degree angle. A is opposite, 75 is adjacent. Opposite, adjacent, I use tan. So tan 38 equals A over 75. So A is 75 times tan 38, which is 52.5 meters from the ground to the top of the building. The large triangle, so side B is in the large triangle with a 51-degree angle. B is the opposite side, 75 is the adjacent. So again, we're using tangent, but this time the angle's different, 51 degrees. So tan 51 equals B over 75. Multiply 75 and tan 51 to get B, it's 92.6. X, the height of Godzilla, is the difference between A and B. So B minus A gets us X, and that's about 40.1 meters. So We have a wordy question. We need a wordy answer. So therefore, Godzilla is 40.1 meters tall. Turn your page over and there's one more example to go through. Example 3 says 2 buildings are 41.6 meters apart. You can see that in the diagram. From the roof of the shorter building, so here's the shorter building from the roof, the angle of elevation to the top of the taller building is 44 degrees. So looking up to the top of the other building, it's 44 degrees. That's where this comes from. The angle of depression, so that's looking downward, to the base of the taller building is 29 degrees. So that's where this 29 degree angle comes from. From here, looking down, that's 29 degrees in there. Determine the heights of both buildings to the nearest tenth of a meter. Okay, so we need to find the height of the shorter building and the height of the taller building. So I want you to notice that there are some labels already on here, X and Y. X is the distance from the ground up to this point. Now if we extend that over here, this is X as well. So X is the height of the shorter building. So we can look at this triangle and solve for X. We know the length of this side is the distance between the two buildings, which is 41.6 meters. This is our reference angle. X is the opposite side. 41.6 is the adjacent side. Opposite, adjacent. Hey, tangent again. All these questions we're using tangent. So I can solve that. Tan 29 equals X over 41.6. If I do the work, X is 23.1 meters. In this other triangle, I can solve for Y. Y is opposite to the 44 degree angle. 41.6 meters is the adjacent side. Again, tangent. So tan 44 equals Y over 41.6. And if I do the math, Y is 40.2 meters. So I know X, which is the height of the shorter building, but I haven't actually answered the question because I need to know the height of the taller building, which is not Y. It's a combination of X and Y together. That's the total height of the tall building. So to answer the question fully, I need to add X and Y to get the height of the taller building. So it's about 63.3 meters. Wordy question gets a wordy answer, so I can write, therefore, the short building is 23.1 meters tall, and the tall building is 63.3 meters tall. And there we've answered the question. I went through that one fairly quickly because the math is pretty much the same as what we've seen in the previous examples. I have a challenge question if you're up for the challenge. The horizontal distance between two hydro poles is 86 meters. The angles of elevation to the tops of the poles are 14 degrees and 17 degrees as measured from a point halfway between the poles. What is the difference in the heights of the hydro poles? So I've got the final answer on the screen, but I'm not showing any work on how to get to that final answer. If you're up for the challenge, you can either by yourself or with a partner try to work through this problem and see if you can get the same thing that I did and challenge yourself. See if you can do it. That's what it's all about. After that, there are practice questions listed on your handout that you've been following along with. So work on those and let me know if you're running into any issues.